This stuff has the industry more hyped up than a caffeine-addicted toddler. And it may leave you asking questions like, is the hype warranted? Is the singularity near? And how do I leverage it, most importantly? So we're going to find out. In particular, I want to cover these three topics. I'm going to define some terms, like what are we talking about when we're talking about AI today, or generative AI, and how does it work under the hood? And then we'll go a little bit into prompt engineering, which if you're building an application that uses AI, a lot of your work is going to go into how do you prompt it? How do you talk to the AI? Oh, and then finally, we're going to talk about the actual application development, where I'll show you an application that I put together for this talk. So let's talk about, first, a little bit about my favorite subject, me. So my name is Phil Haack, and I know what you're thinking. What a great name for a software developer, Phil. I'm on Threads, I'm on Twitter as @hacked, and I also have a blog at hacked.com. Oh, well, you can't even see that. I can see it on my machine, but if that doesn't show up, that could be a problem. But it's @HAACKED. And when I got my first computer when I was around 5 or 6, a TRS-80 color computer. I know I look kind of old for 5 or 6 back then. But I've been in love with computers ever since. I'm most well known for working on ASP.NET MVC and NuGet and GitHub back in the day. So I am not known for or an expert in natural language processing or AI or any of that. However, in the last 3 years, I've been working on a company that has been leveraging these technologies. And the key thing is you don't have to be an expert to use it in your application and use it effectively. But the more you know, the better you're going to use it. And so to get started, let's define some terms. For example, what exactly is AI? It feels like, is it magic? So AI, or artificial intelligence, is a machine capable of performing tasks that typically require human intelligence, such as, what's in the image recognition, what's in this image, or categorization, or text and image generation. AGI is a term you often hear, or artificial general intelligence. This is AI designed to learn, think, and perform at human levels. This is the AI that can reason for itself, take on any sort of task except opening the pod bay doors. And this is the AI that you often see depicted in movies, and a lot of people breathlessly say, oh, AGI is here. But it's not. This is not the kind of AI we're talking about today. This is not the kind of AI that exists yet. AGI should not be confused for generative AI. And this is the type of AI that has exploded on the market recently. This is AI capable of generating text, images, or other media using generative models. So generative models are fed these ginormous data sets, and they're programmed to learn patterns and create new data that mimics those patterns. And mimics is the key word here. Monkey see, monkey do. The data-driven mimicry is a key aspect of the current generation of AI technologies. For this talk, I'm going to focus on LLMs. So yet another TLA. LLMs, or large language model, is a deep learning algorithm that can perform a wide variety of natural language processing tasks. And there are many of these out there now, like Claude and probably some others I'm forgetting. But in particular, I'm going to be covering GPT by OpenAI. And I don't have any kind of special relationship with OpenAI. It's just the one I've been using lately. And GPT stands for Generative Pre-training Transformer. So this is a language prediction model that uses machine learning to produce human-like text. And you notice I highlighted a couple terms here. This is your clue that this is not AGI. This is not general AI. We're doing predictions, and we're generating human-like text, but we're not doing symbolic reasoning or anything like that. Now, a philosopher might say, well, how do we know that that's not how our brains work, that we're not just predictive models as well? And we don't need to get into that in this talk. That's a whole nother talk, right? So let's talk about how does GPT work. So here's the original schematics for GPT-1, but then they've since improved it. So this is a complicated diagram I put together. Unfortunately, some of the colors are not coming through, but don't worry about it. I'll explain what's going on here. So the first, I'll go into more detail, but first we have a prompt. That's your text that you're going to feed into the AI. It goes into a tokenizer, which is a simple algorithm where it assigns each word, or not each word, but although it's easy to think of it that way. It assigns each thing a token, and then that goes into the encoder, which then spits out a giant matrix of numbers. And that matrix for GPT-3 is so let's say is about each token has a vector associated with it. So if you remember way back in math class, a vector is an array, right? So an array of numbers. And there's 768 numbers associated with each token after the encoding process. And I'll explain a little bit of what are those numbers about. And then we go to decoding and we get the result. So the first part, the tokenizer, it's very helpful to play around with the tokenizer, see how it works. And there's something called, OpenAI has their own, but I really like this one by someone named Simon Willis. Let's see if I can click, open link. Oh, that's not showing up. Let me see. Displays. Oh, do I need to move this to the other monitor? Ah, okay, that's going to be, I can't do that. Sorry, I think I'm going to, as I switch back and forth, I'm going to have to switch from mirroring to non-mirroring, which is going to be very, where is mirror? Okay. Okay, that's fun. All right, so this is a GPT token encoder and decoder. So we can do things like hola, hello, NDC Porto 2023. I parked the car at the park. And the reason I chose this sentence here, it may be hard to see. Let me zoom in here. Oops. You can see that each token is getting assigned a number, and some words are broken into multiple tokens, right? But you can see here, like park here and parked. Let me just change that too. At this stage, when we're tokenizing, we're not yet applying meaning to these words, right? Because this park and this park has a different meaning. The other thing you'll notice is that each of these tokens has a space in front of them, and if I started the sentence with park, it'd be a different token, whether it's capitalized, so 25478, or lowercase. So it's just kind of like how it tokenizes things, so that when it puts things together, it knows whether a word's in the middle of a sentence or not. So let's get back. Okay, so what's going to happen here? Oh, darn it. I bet there's a smart way of doing this that I do not know, so I apologize in advance. So now I have to switch back to stop mirroring and hit play. There we go. Okay, so that was tokenization. The next thing I want to talk about is the encoding process. So there's supposed to be errors in between this. So I mentioned before that the encoder spits out this giant matrix. And let's say the prompt is once upon a time, not long ago. And then that gets fed into the language model, and which then does this churning, and then it looks at the probability distribution for this matrix. So you can see here, we have, it's like every token. This probability matrix goes over every single token in the system, and it then basically rolls some dice and picks one of the words, based on that probability distribution. It doesn't always choose the most likely next word, unless you set the temperature. If you ever mess around with GPT, you'll notice there's a temperature. You can set it to 0, and then it always picks the most likely word. But it turns out by throwing in a little randomness, you get sublime results. So then it takes that, and it spits out the next token. And then the key thing to understand here is that each time you're running a prompt, all GPT is doing with your prompt is spitting out a single token based on all of that processing. And then what it does is it adds it back into that matrix of embeddings and encodings, and then spits it through the model again. And now there's a new probability distribution, and then it picks the next token. It takes that token, spits it back in, and so on and so forth. You might be wondering, where is it getting this probability distribution from? Well, that's all the pre-training. That's that, the P in GPT, where it took the huge corpus of data, trained it on that, and it figured out, when I see a matrix that looks something like this, here's the probability distribution token. And so as you realize this, you realize that it really is just predicting tokens. It's not really doing any kind of actual reasoning or thinking, right? But the results you get can be pretty amazing, right? Can anyone guess what the next word is? Anyone know this lyric? Okay, it's pajamas. All right, so what are some use cases of this type of model? Summarization, classification, translation, text generation, question answering, and many others, right? And what we know is that GPT's strengths are generating human-like text, but its weaknesses is that it sometimes stumbles over facts and is inconsistent. And there's also, the larger societal weaknesses that we're still trying to figure out how to contend with, right? Like disinformation campaigns, deep fakes, all these different things. So I'm going to show an example of this. Let's see. I'm going to see if I can do this. Open. Will that work? No, that didn't. Okay. All right, I'll get better at this. Oops. As we go. Can you see that? Oh, great. So what I'm going to do here is type in a prompt. So let me zoom that in. Write a Wikipedia article about Phil Haack, who worked at Microsoft GitHub, aka me. And let's see what it does. So what's great is it's making up an image about me. Uh-oh, I hope the internet connection here is fast enough. So you notice here it has a broken image because it just made up, oh, well, Wikipedia article has an image of the person, so I'm just going to make one up, right? It's predicting what you want to see. And it's like, born on December 12, 1974, false. Prominent software developer, I'd like to think so. Known for his contributions to, his work at Microsoft GitHub. So a lot of this is good. A lot of this is true. But, I was born in Michigan, but not Ann Arbor. And so on. So this is kind of fun to see how it does. But let's do a really simple problem. This is something computers are really good at, right? Multiplying. So I'm going to, okay. Why is it, dang it. Okay. Okay. Yeah, okay, let's stop generating. So unfortunately, I think so we're going to ask it, what is, come on. Okay, 3,039,000, let's take a calculator. Let's take these two numbers, and this is something anybody should be able to, anybody can write a program to do, but you see here, that value is wrong, right? So for all the amazing things GPT can do, it can't multiply two numbers. I'll show you how to fix that later, but it cannot multiply two numbers. So let's get back into it. And stop mirroring, and let's go back to my talk. Okay. All right, so let's cover prompt engineering for a bit. I mean, this could be a whole talk in its own right, so I'm going to kind of breeze through things really quickly, and I'll cover some key points. So prompt engineering is the art, and I use art meaningfully here, of giving an AI instructions to try to coax the right result, or a useful result, right? It sometimes feels like you're making a wish to a genie, like you have to really think hard about how you present your question to the AI. You have to be very intentional with the input. So the prompt is natural language text sent or received from an AI. And I mentioned before received because as you saw how it generates text, it takes each thing it generates and puts it back into the prompt, right? And so if you ever use the GPT and you know there's prompt limits, that limit is for the entire thing. So it's the input plus the generated output. And so when you're figuring out your prompt limits, you need to work some logic into there to make sure that you leave enough room for the output, that your prompt doesn't get too big. Plus, those tokens cost money. So the larger your prompt, the more you're spending on GPT. And GPT has three key roles here: system, user, and assistant. So the system prompt sets the overall context, typically used to configure an AI in some way. So when you're using the website, you don't get to see the system prompt, whether you're using Bard or GPT's website. But when you're building an application, you have control. Excuse me. You have control of this. You are a pirate of the 7 seas. Like if you want your GPT to speak like a pirate, you might use that as the system prompt. The user prompt is the question you're going to give to the AI. So translate this text into Klingon. And then the assistant is the response. Nukne gak jmesh. I have no idea if that's how you pronounce that, but I don't know Klingon. But GPT does. So some prompting best practices. Start simple and iterate. Start with the simplest thing possible and then iterate towards a useful response. Be direct and specific. You can often get good results when you specify the tone you want, be polite. When you specify the length, in 100 words or less. When you specify the style of format, please format this as a list of bullet points or JSON. And then a scenario, you are a professor of history. Put the instruction first, and start the user prompt with the main request, translate this, and then add the context after that, and as much context as you feel is necessary to get a good response. Okay? See, that's bad AI right there. That was Siri saying, check it out. Provide examples. You can provide examples in the system prompt or by pre-populating user and assistant prompts. And a lot of folks don't realize that second part, and I'll show that in a second. And then experiment. Word choice, ordering, personas, all of these can impact the results. The other thing, be positive. And I don't mean this in a saccharine way. Nike was on the right track when they said, just do it. What I mean is, if I told you right now, do not imagine pink elephants flying around the ceiling here, the first thought in your head is, oh, pink elephants flying around the ceiling. Understand how the generative AI works. By introducing the context, it's trying to predict what words are related to that concept, right? So if you say, don't generate anything about pink elephants, you're often pushing it to do so. Want it to do. Do generate things about something else, right? And then give the model an out. Let the model say, I don't know, to try to reduce hallucinations. So hallucinations is this term of basically when it generates false facts, right? Predicting text that it's predicting text that it thinks you would want from the prompt, and sometimes it just generates meaningless or wrong facts, like it did with my Wikipedia article. And so giving the model an out is one way to try to reduce that. But you can never fully get rid of hallucinations. Break complex tasks into subtasks. So if you wanted to write an essay, you might say, write 3 statements for this point, write 3 statements against, add a conclusion, and then summarize it into an essay. And by giving it discrete steps, it will often produce better results. You can ask it for its chain of thought. And this is a very powerful approach. Okay, ask a question and then say, okay, how did you come to that conclusion? And then sometimes just checking the model's comprehension. You might say, oh, wait. Oh, you're kidding me, come on. Oh, so he's like, are you sure about that? Are you sure about that? It's really funny, I swear. Okay. But I don't know why it's not working.
You sure about that?
Oh, now it's going.
You sure about that? You sure about that?
So you ask the GPT, are you sure about that? And sometimes it produces good results. If you ask it, are you sure about that with the multiplication example, though, it'll keep giving you wrong answers. It's really funny. It's like, oh, I'm sorry, you're right, I'm wrong. Here's the right answer, and it's wrong. Okay. So the best tip I can give you is to play around with the platform playground, the OpenAI playground, platform.openai.com/playground. And let's do that. Okay, so this is okay. So we're going to go to platform. Oops, not there. Playground. So what's cool about this is you can control the system prompt, you can control the user prompt, and so on. So we're going to start with something. I'm going to ask it a question. So it's Andreas passes the ball to Joao. Joao dummies the ball. Oh, I forgot a period here. Oop. I'm trying to use these shortcuts so you don't have to watch me do all this typing, but okay. There we go. Joao. Joao dummies so Andreas passes the ball to Joao. Joao dummies the ball, and it goes to Lewandowski, who scores a goal. Who gets the assist? This is a soccer question, or football here. Whoops. And, submit. And then we're going to see what happens here. So it says, in this scenario, Andreas gets the assist because he directly passed the ball to Joao, who then dummies it and creates an opportunity for Lewandowski to score. So this answer is correct. This is a real interesting example where it seems like it's actually reasoning. Even though Joao dummies the ball, to dummy the ball means you fake like you're going to touch it, but you didn't actually touch it. And since he didn't touch it, he doesn't get the assist. So this is one of those examples where GPT is really good, right? So now we're going to add a system prompt. So we want it to be even better, right? So you are a world-class soccer referee bot. Please provide an answer in reasoning in JSON format. So I'm going to go ahead and submit that. Oop. And you see assist Andreas. So you notice here, like, it didn't do a great job because what would help it is giving it an example. So I'll give it an example in the prompt. For example, and I like to use delimiters when you're giving examples or code blocks. So, we're going to say, what? Oh, zoom in. Sorry, yes. Oh, yeah, it's much smaller up there. Okay, sorry about that. Yes, good way to ask. Okay, so we're going to say answer. The answer. Oh, my goodness. Let me type. And reasoning. So now I'm giving it a template for how I want it to respond, the reasoning. And then I'm going to submit this, and we see that, great, it's doing a pretty good job of that. But let's say, I'm actually going to feed this, I'm building an application, and I want the answer to be as short as possible. I just want it to be the answer and let the reasoning have all that context. So one thing we can do, and I mentioned this before, is we can take the assistant prompt. I'm going to edit this and just say, a one-word response, Andreas. Okay? So now, here's the prompt. It's a system prompt. I'm going to pre-populate the user and the assistant prompt, and now ask another question. So what would be a question I might ask? Let's ask an offsides question. Offsides. Oh, okay. Can a player be offsides in their own half? This is an easy one. Okay, and now we see that I'm getting the type of response I want. Oh, let me scroll back up. So it gave me a yes/no answer, no, and then it gave me the reasoning. So if I was building an application, I might actually build up the prompt using the API to have the system prompt, an example user, and an example answer, and then dynamically take the user feedback and create the next user answer stuff. And by keeping those examples as part of the prompt, you get better results. Okay, I think that's all I wanted to show there. So, okay, so that's, okay, so I demoed that, great. All right, so let's talk about the app. So I've built this app, and I wanted to set up like a realistic app. So I set up ASP.NET Core with EF Core, SignalR, Tailwind, React, use Refit. And then I used the azure.ai.openai library. There's multiple libraries you can use to communicate with GPT, OpenAI's API. I like this one just because I know that they're supporting it, right? That they have full-time employees working on it. And this is the URL for the docs. So after getting all that set up, I kind of ran out of time and didn't actually implement anything. No, I'm kidding. I've got something to show you. So let me show you where you're going to get the API keys. Okay, so if anyone knows a better way to be switching back and forth, I would love to hear it. I would just wish it would automatically switch from one to the other. Oh no, I did the wrong thing. I didn't want to extend it. I wanted it to mirror. Okay, great. So when you're in GPT, you can go to your API keys. You're going to create a new secret key. And then you're going to store that securely in your application using user secrets if you're an ASP.NET developer, right? Or Azure key management or AWS key management. I think Azure calls it Vault. And then we're going to go to this application. So I'm going to go ahead and run this. Oh, that's really small too. Okay, let's see. Can I increase the size? Okay. So the way that you normally do this is not working right now. Okay, there must be another way. What's the fastest way to increase the font size in Writer? Anyone know? Control plus, right? That's Command plus is what? It's not working. That's the weird part. I swear I did this earlier. Okay. Oh, scroll it? Command scroll. Okay. Man, this is really, okay, let's, can you kind of read that, or is that really too small? That's too small, isn't it? All right, there's like a file, what was it, settings. I'm gonna, yeah, it should be on the bottom, but I don't see anything. Font. Presentation mode, how do you do that? Oh. Okay, 24. Oh. There, thank you, okay. Thank you, okay. Sorry about that. Like, I had no idea going into it how small the screen was going to be. I should have thought of that. But it's really weird that plus plus, or that the command plus should work, and it's not. But we'll worry about that later. Okay, so what was I going to do? So this is the application. I'm going to run it so you can kind of see roughly what it is. Okay. It's taking its time. Uh-oh. Are you kidding me? I think the demo gods are not kind to me today. Okay. Let's try that again. Yeah, if I can't run this, that's going to be, okay, good. I wonder if that's because I'm on a different network. Like, that didn't happen. Oh, look, see, now it's working in Chrome, so you know I'm hitting the right key, but it's not working in Writer. Okay. So I've got a few things. What we're going to build here is Ask the AI. So sign in with GitHub. Oh, wait, actually, this I know why. So I actually wanted you all to be able to log into the chat. So it's bit.ly/hack-AI. And you don't need to do it right now, but if you want to later, like we'll all go in the chat. So here's a typical thing that you might have, right? We're going to ask a question: how tall is Mount Everest? This is pretty basic, and hit submit, and then we wait a minute. Hidden in the details is the system prompt, and so I'm allowing you to play around with the system prompt, and we see that it's not working. Okay. So let's take a look at the code. So I'm going to go to, so I have a page called ask.cshtml.cs. We bind a question, and then we create this chat completions options object. And this has the message. So here you can see I have the system prompt in the system role, like I showed you earlier. And I don't have any pre-populated assistant role ones. And what I'm going to do here is I'm going to take, oh, I see the problem. So we need to add, now I could do it right in here, but I'm actually going to do it out here. So options.messages.add. And what we want is a new chat message with the role, chat role user. There it is. And the question. So let's run that. And so this is the, this is the API for calling this. Let me just show you here. So we build up this options object. It has the set of messages. And then you call get chat completions, and then you retrieve the answer from the choices. Now, there's only going to be one choices unless there is a way you can pass a parameter, say, give me 5 responses, and it will give you 5 different responses to the same question if you have temperature not set to 0, right? If you have that randomness. But I didn't pass that. I only want one answer. And now let's try submitting this again. And beep, boop, beep, boop, beep. That's the official sound. So we see Mount Everest is approximately 8,848 meters, or 29,000 feet. But I might be like, well, what is that in miles? Because I'm an American. What is that in miles? And what do you think is going to happen here? Form a hypothesis. You saw the code, and it's saying, hey, I need more information to convert something into miles. Could you please specify the unit amount? So what's happening is when you use GPT on the website, you notice it actually maintains the state. And what it's doing behind the scenes is it's taking your conversation history and sending that entire thing back every single time. So the first time you use the API, you might think the API works that way, but it doesn't. The API doesn't maintain state for you. You have to maintain that state. So we're going to do that, and what we're going to do here is I'm going to add a property called previous messages. Previous messages. And we're going to bind it. So anyone here not use ASP.NET Core? Because I just want to make sure if I need to explain like any of that. No? Okay, y'all have used C#. Okay, great. So we're going to make, oh, actually, previous messages is not required. We're making it nullable. And so what I want to do here is we're going to add, so where should I store the previous messages? Probably maybe in a database, in a cookie. I'm just going to store it for now. For demo, I'm just going to store it right in the form as a hidden input. View state, anyone? Right? Type equals hidden. Name equal, or actually, ASP4, previous messages. Now, I shouldn't have to do this next part where I set the value because it should just read it through binding, but for some reason it wasn't working and I'm not taking any chances. We've seen how my demo's going so far with everything going wrong. Okay. So the idea here is, well, I have this property where every time I post back, I'm going to post back the entire history of this conversation. Now, in a real application, it should be a window of the history. You might summarize the previous messages because you don't want that prompt going too big. We don't have time for all of that, so I'm just going to do the simplest thing possible, right? So now what I want to do is I need to grab that previous message and then deserialize it into a set of chat messages, right? So I have a little code I wrote ahead of time. Sorry, Siri keeps responding to me. I should have shut that off. But so I wrote some extension messages because, unfortunately, using this OpenAI library, they use their own struct type for the chat role that doesn't serialize or deserialize with the default serialization options. So I just wrote my own classes for mapping the serialized to the form to the original object type. So the key thing here in this block is I grabbed the previous messages, and then from the JSON representation, I deserialize some messages, and I put them back into the options. So that will be, right after the system prompt, will be the previous user assistant. And then, oh, we don't need that. And then what I need to do here before we render the page is I need to take the new history and send it back in, serialize it back into previous messages. So I'm going to AI serialize. There we go. Oh, you know what? I did init. That should just be a set. Okay. So now I'm taking the options, the serialized options. I'm skipping the system message, and then I'm putting them in previous messages. Okay? So now let's run that and see what happens. So I'm going to have to, let's go back into here, ask the AI. So now when I ask, how tall is Mount Everest? And then I'm going to ask, okay, what is that in miles? And we should see that the state here is maintained. And it's going, oh, it's approximately 5.5 miles tall. So as you build your application, that's how you're going to maintain state. Now, again, in a real-world app, you're going to need to figure out how to truncate those tokens, right? That window. OK. So that is showing off the completions API. So this is what the message looks like in raw JSON, right? You got a set of the model that you specify. I'm using GPT-4, and then the set of messages. So let's talk about GPT functions. How do you deal with live data? How do you deal with computation? So you recall when I said multiply two numbers, they didn't know how to do it. But we could give it a way to say, well, you know, for something like that, you should call me, and I have some processing power I can lend you, and I'll do calculation for you. So we can describe functions that are available to our model, to our app, and have the model intelligently choose to output a JSON object containing arguments to call those functions. So this is how GPT works. The key thing to know is it's not like the Hollywood principle, don't call us, we'll call you. It's more like, don't call us, we won't call you, but we'll tell you who to call. So it will give you a JSON object, and then you have to interpret that and call whatever it is. And then you take that output, and you pass it back in. So here, this is a lot to look at, but here's an example of a GPT function called arithmetic. The key thing here is the description is the prompt for this function. So it says performs arithmetic operations. So when you prompt it with something like, hey, what is 5 times 5? It hits that prompt, and GPT say, oh, I know what to do. I need to call this function. And then you describe the properties of the function. There's 3 parameters, left, operation, and right. You give it a type. The description is also a prompt, so it knows like what part is the left, what part is the operation, what part is the right. And then you specify which one's required, you know, so left, op, right. So what I'm going to do is I'm going to take that, and we're going to write a GPT function. We're going to write it the hard way, and then I'll show you something neat that I did. Whoop. OK. So it turns out it's a lot smoother if I just don't use my notes. So I think I can get through the rest of this talk without my notes. So let's do a function call. So here, when we're doing these chat completions, we need to add functions. And this is going to be a new list of function definitions. So I actually wrote this out a while ago, so let me just pop that in there. I know it's cheating, but let's see. Did I do this right? Bam. OK, here we go. Oh, new list of function definitions, and then list initializer, and bam. OK, let's indent this and complete it. Bam. OK, there we go. So let me walk through this real quick. So this looks pretty much like that original JSON format, right? Name, description. I elaborated a little bit for the sake of the argument. And then parameters. And with the OpenAI, the Azure library, you use this binary data.fromObject as JSON. That's their method. And then you can pass in this anonymous object. Now, when I first wrote this, what I did is I took my example JSON, I posted it in Chat-GPT and said, turn this into an anonymous object in C#, and it spat out this. It was impressive. That's an example of where it's very good, converting one type of code to another. So this is the same thing we saw. And now the thing I have to do is, OK, so I've told it about this function. So when we ask it an arithmetic, it's going to respond back saying, oh, you asked for a function call, and it's going to give us JSON. So we have to look for that, and then we have to respond to call the function. So I'm going to write a method. So notice here, return page, I'm using a method within a method. So we're going to call call func. So this is going to call the function given a chat message. And so the key thing here is we deserialize the arguments into this type called arithmetic arguments. This is a type I wrote. So it's basically maps to left, operation right. And then operation is an enum. And then we're going to do the arithmetic. We're just going to do that computation, right? Pretty straightforward. The key thing here is we need to take whatever it gives us, deserialize it, and then we do the work. And then we're going to take that result. So the result here is the arguments with the answer. So I'm using a record type there. And then we're going to pass it back into get completions and say, oh, here's the answer. And then it's going to summarize the whole interaction. So the last thing I need to do is here, where after I call this, I need to check for that option, right? So I need to look at, we're doing a pattern matching here, value.choices. We're going to match an array, and then we're going to await call functions with the message. So let's grab that message. So here we're looking at the message property of one. So we're doing a list pattern. We're only looking for a value.choices where there's a single entity with the message property, which we'll assign to message. Let me add that comment here. And just to be safe, we're going to check that the message has a function call .name of arithmetic. It's important I get that right, because I might have multiple different functions, so I want to be able to dispatch it accordingly. And if this seems like a lot of boilerplate, it is, and we'll get to a better approach. But I wanted to show you the hard way so you understand what's going on under the hood. So here we're saying if we get a response that says call this function, we'll call that function. And then I think that's all I need to do. So let's rerun. And so add.multiply, I think that was. So now we're going to ask this question. What is 32412 times 93823? Let's bring up the calculator so we can compare, submit. Wait a second. Fingers crossed. Did I hit the submit button? OK. And we see we get a correct answer. Yay! And so let's step through the debugger and see kind of what's happening there. How are we doing on? OK, we're doing OK on time. Stop debug. So I'm going to submit this again. And we should hit this point. And so we get response, value, choices. There's a single choice, chat choice. So we see the finish reason is a function call, and the message is a function call, and there's our argument. So I can't zoom in. So we can see that's the response it's giving us. Hey, please call this function with these arguments, right? Okay, so the next thing I want to actually, before I get into this, so you might have noticed that was a lot of boilerplate. So I wrote, I'm always thinking about how to write frameworks to do things that I don't like to do, right? So I wrote a little interface called iChat function, and it's very simple. It has a function definition and an invoke async method. And then I wrote a base class called chat function that simplifies it even more. I'm going to make all this open source at the end of this talk, so you don't need to try to understand this. But the key thing here is let's look at the weather function example. And this is the example that they always use in the GPT docs. So with the weather function example, you just inherit from chat function of weather arguments, weather result. So you define a type for the input, a type for the output, and then you define a method, invoke async, that returns the output given the input. And that's it. And obviously you specify the name and the description. And now, by doing this, I'll automatically render all those function definitions in the completions, and I'll dynamically dispatch to your function call when GPT says, oh, I need that function call. And that's done in the function dispatcher. This is where we get the function, we dispatch it. It's pretty straightforward. So let's look at a more interesting example. Let's say you want to work with live data. And for example, in my chat application, I implemented, using SignalR, a little chat app. We can go in there and we can talk, but you can also call out to the bot and tell it things about yourself, and it will remember that. And then later, you can ask it, does anyone know Spanish, right? And then it will look through and it'll figure that out. And the way that works is embeddings. So a lot of times when you think, well, how do I give access to my internal data, right? I don't want to post my internal data to the public, GPT. One way is you can train the model. But it turns out that a lot of times training is not what you want to do. It's very expensive, and you can get really good results by using embeddings. So what embeddings are is they measure the relatedness of strings. So you can create an embedding from text by posting to this API, embeddings, and it just takes two things, input and a model. You notice here the model is not GPT-4. We're using text embedding ADA 002. That is the model they recommend for embedding. You get good results, good price per performance profile for that. You pass in your text goes here, it's going to return something like this, data, embedding, all this other stuff. The important part here is the embedding part. Again, remember I said before every token gets an array? So this is a set of numbers that measures the relatedness of tokens in that prompt. And so I think closer to 0, they're like orthogonal, and closer to 1, they're highly related, or I may be getting that wrong. But then we use this thing called cosine similarity to compare your embeddings to your new text. And the way I wrote that is I went to GPT and said, how do I calculate the cosine similarity of these two vectors? And it gave me a pretty good implementation. But then I checked my work against a real implementation in Python, because never trust the code that it gives you back, right? So let's look at what does this look like in practice. So I have a store user fact function here. So this is another GPT function that I'm going to expose to ChatGPT. And here it says, stores information about a user when a user says a fact about themselves. So again, that's the prompt. And then what I do here is, in my invoke async, I get the arguments, and then I'm going to try to retrieve a user. I'm going to generate the embeddings. So that's just calling the getEmbeddings API. And then I'm going to store that embedding with the user, so you can see here. Now, this demo is using Postgres. Postgres actually has a vector extension called pgvector, or you might use a vector database. The way I'm doing it is not the performant right way to do it, but it works, so it's good enough for a demo. But when you start to store embeddings, you're going to want to use something like a vector database. And let me show you why, because there's the part where we're going to retrieve the user function. So the prompt here is, retrieve information about a user when asked about a user. So what I end up having to do is, given the question, I'm going to get the embeddings for that question. And then I'm going to grab all the users for the user that it's asking about, and I'm going to calculate the cosine similarity. And let me show you that code. I don't know if you remember way back in math, dot product and all that stuff. It's like, when I was in math, it's like, when am I going to use this? Well, if you do natural language processing, you're going to use it. Or you're going to copy someone else's code who knows what they're doing, which is what I did. So we calculate the cosine embeddings, which gives you a similarity score. And then I'm going to only return responses that have a score of 0.8 or higher. And that's really a judgment call on your part. You experiment, you see what works, and then I'm going to respond back. So let's see this all in action. So if some of you want to go to bit.ly/hackedai, we've got this chat application. All right. And this chat application is Hello World. It uses you have to authenticate with GitHub, and it won't steal any of your information. You notice here, it's not doing anything. If I open up another one, you'd see it. It's using SignalR. If anyone logs in, just say hi, right? But I can also do, hey bot, how tall is Mount Everest? And so I have it configured, when it sees hey bot, it's going to call GPT. Now, you could have your app listen to every message and then determine when it should respond. The other thing I did, oops, whoa, what was that? No, don't do that, is F12, okay. Hey bot, what was it? What is the weather in Porto, Portugal? I mean, it doesn't take an AI to know it's rainy, but one of the things I want you to notice here is oh man. So what I'm doing here is I'm using custom console. So this is a React app. I'm using custom console messages to show what is going on under the hood with the AI. So with every prompt, I ask it to also provide a reasoning, and that's where I'm piping it into. So it's hard to see here, but it says the message addressed me, I'll try to respond. I have a function that can help with this call. I'll call get current weather, location Porto, Portugal. And I got a result. I'll send it back to GPT to summarize. So I might say something like, hey bot, I am currently in Porto. Now, that's noticing I'm saying a fact about myself. So it says, oh, I have a function that can help with this. I'll call store user fact. Username hacked, fact, I am currently in Porto. OK, got it. So now I'm going to refresh, because I'm also storing these prompts in the prompt and sending it all back. So it would know I'm in Porto just by the fact that it's currently in the session. So I'm going to stop this one and restart it. Let's go to, and now I'm going to ask it, hey bot, where am I? So now it's taking that prompt, it's generating an embedding, it's getting all the facts it knows about me, and it's and it's failing. Okay, wait, hey bot, where do I live? Okay, this one I've pre-populated. So it's generating embedding, passing it in, comparing it to all the facts it knows, the embeddings for all the facts it knows, and returning one that has a score of higher than 0.8. Oh, let's see what retrieve unit hack. Where does user live? Justification. The user asked for his living location. I need to fetch that. And let me do a hard refresh. Let's try this one more time. Sometimes I run into problems where a Signal-R connection gets broken. So I can actually go into here and see like all the embeddings. So you see all those vectors. So it could well be getting confused by all the facts that I've already added. But let's try it one more time. OK. Hey, bot. Great. Hey, bot. You have to start with hey, bot to have it store where you are. Hey, bot, where do I live? OK. All right. OK, I live in Bellevue, Washington. Now, what if I ask, hey, bot, what is the weather where I live? So it's trying to get the current weather, location Bellevue, Washington. Wait. Oh, let me refresh that. Sorry. Sorry, that was one case where it sort of worked when it wasn't supposed to because I'm trying to make a point here, but let's try it one more time. So I'm going to chat with the AI. I'm going to ask it, hey, bot, what is the weather where I live? I'm going to hit F12. Oh, so it's 3:17 a.m. I was wondering, why is this in dark mode? It shouldn't be in dark mode. My laptop didn't update to local time. It's 3:17 a.m. where I'm at. It's probably thinking, what the hell are you doing on the computer, right? So you notice here, the bot tried to respond, but it couldn't. Why? Because it got back a function call. First, it needs to know, where do I live, right? So it's giving me JSON, and then the bot didn't know what to do with it. So if we go back into my code, we can fix this, right? So I'm going to look for, I believe it's in chat function. Or is it? No, it's not there. It's our result. OK, at some point where if function call. There it is. Where is it? Oh, chat message consumer, yeah. So basically, earlier I mentioned if the finished reason is a function call, we need to pass that response back into GPT to summarize. But what if the result of that is also another function call? Well, we can fix that by just using a while loop. While the finished reason is a function call, we'll keep chaining these function calls over and over again. Now, it would be wise to have like a sort of a circuit breaker, like put a counter, and if the loop is over 5, stop because you made a bug in your code. But let's live dangerously. So I'm going to run this again. I'm going to refresh this. OK. Hey, bot. What is the weather where I live? And what we should see here, beep, boop, beep, boop, beep. OK, so first it called retrieve user fact, and it said, oh, well, in order to answer that question, I need to know where you live. So it retrieved the user fact, and then it got that response and it's like, oh, well, there's still the open question of what's the weather? Well, I know where you live, so I need to call another function, get current weather. And now it has that location, so it passed the result of the first function call into the second one, and boom, now I get a full response. So this function chaining is really powerful because as you build up a set of useful functions, you can chain them together and start to give your model, your AI, in your application superpowers. Hook this up to Wolfram Alpha, for example, and now it'll start giving you accurate answers about science and quantitative questions. So very powerful to use GPT functions and to chain them together. Now, there's existing projects like LangChain that do this sort of thing. I haven't played around with that enough, but from what I understand, like GPT functions, when they added that, it reduced the need to use something like LangChain, but then LangChain rebuilt on it. So another example is you can expose your database, your data schema, to as a GPT function, and start to write natural language queries against your database, and give it to your business people, like, how many products did we sell in Q2? Boring questions like that. So that's it for the demo. I have a few resources up here. I'm going to try to see how I send out my slides after the fact. And before I forget, the GitHub repo is called github.com/hacked/AI demo. And I will, if I go to settings, and let's see, I think we're going to change the visibility to public, and it's going to be, yes, I understand. Wait, did I do it? Change the public. I want to make it, I have read and understand these facts, make this public. Wow, it's very secure. I'll do it later. Okay, I'll do it later. But so these are useful resources I found for understanding it and for playing around and building my applications. Thank you very much. If you have any questions, just come find me afterwards. I'll hang around here and answer questions. Or actually, just... Yeah. Oh, okay. Yeah. Yeah. Yes, the description is the prompt. So it's going to try to match it to the prompt. And then if more than one apply, it's going to call them in order. So important there. When I did my example, it needed to figure out who I am. But sometimes it's smart. It knows it needs to figure out who I am or where I live before it can answer the weather function. So that part was all it. And that part was cool. But a lot of times, you're going to order it in order of priority. Yeah, but yeah, it feels like magic in that regard. Like, the part where, so I wanted to understand what would happen if it didn't have all the information. What would happen? And I was like, oh, let me just try a while loop here. Or actually, no, what was happening was it wasn't working. And then I looked at the code, and I was like, oh, it's responding with a function call with another function call. What if I just do a while loop here? And it just magically worked. And I was like, it blew me away. And I was like, oh, I wish I had known this earlier, when I was building my company. This I learned when I was working on the demo. I was like, oh, I wish I had known that when I was building the company, because there are so many things that we could have done with that, right? So many ways where it's really bad that we could, if Wikipedia has an API, I would call that, things like that. So yeah, it's a very powerful thing that I don't think a lot of people have, embeddings a lot of people haven't played with, because when you first look at it, it feels very complicated. But once you understand, it's really simple. It's just a bunch of numbers and a bunch of useful numbers that you just have to store.